Hi, this is Mrs. Naslin, and today I'll be doing Unit 7, Lesson 12, Expressions and Inequalities. Our learning target for today is, I can choose expressions and inequalities to represent situations and write situations to represent expressions and equalities. Basically, the idea is you can read a word problem or any type of problem and look at it and write the equation that you would use to solve the problem. Or if you're given an equation, you could take it and write a word problem to go along with it. So let's go ahead and get started. On the first ones here, they're giving us word problems, and we have to figure out which expression or which of these ways will actually solve the problem. So let me read the first problem to you. It says, Elena has purchased a phone plan that charges 10 cents for every text message she sends. Circle the letter of expressions below that show the cost if Elena sends one text message each day for a week. So again, I always like to, on word problems, I like to circle my numbers. Cost her 10 cents. I'm going to box important information for every text message she sends. I think that's important to know, okay? So it's 10 cents for every text message she sends. Circle the number the cost of Elena sends one text message each day for one whole week. Okay, there's a number there. One whole week. So first off, there's kind of a hidden question. We have to know how many days are in a week. We know that there are 7 days in a week, all right? And she sends one message each day. And how much do the texts cost? Cent. For each text, it costs 10 cents. So looking at that, I'm going to look at my problems, and I always like to think about how I would solve it before I look at the equations, because for some reason when I look at the equations, I tend to get really confused. It's easier for me to think of how would I solve this problem if I didn't have those equations written. So if I know that she's sending one text a day for 7 days and they cost 10 cents, I'm going to have to multiply 7 times that 10 cents in order to get my answer. And then once I figure that out, I like to check and see if any of those work. So 10 times 5, no, there's 7 days in a week. 10 times 7, yes. And we won't want to add it. That wouldn't give us the right answer. So the correct answer is B. 10 cents times 7 would get us the total cost for 1 week. All right, let's read the next one. When concert tickets are purchased online, each ticket costs $25. And for any number of tickets purchased, a service charge of $15 is added to the cost. Circle the letter of the expression below to represent the cost of purchasing 2 tickets. So on this one, I have to really understand what the question is asking, okay? So first, I'm going to circle my numbers. A ticket costs $25. And a service charge of 15 is added for any number of tickets purchased. So as I understand that, basically each ticket, important information, I'm going to box it, each ticket is $25. No matter how many tickets I purchase, because it doesn't matter how many, for any number, they're going to add on $15 to the cost. That's a lot of money just to add on, isn't it? And then it tells me that I am purchasing a total of 2 tickets, okay? So I know each ticket costs $25. So again, I like to try to write my equation first and then see if there is an expression that will actually help me that is the same. So I know each ticket costs $25. So I'm going to say 25 times 2, right? Because I'm buying 2 tickets. And then I have to add on that really expensive $15 fee on top of that. So I have to add on that $15. All right, let's see if there's any equation down here that matches that. So those are all the same numbers, but that wouldn't work. That's not the right order, right? I said I have to do 25 times 2 first. So then I look here. Nope, that doesn't work either. But here we go. 25 times 2 plus 15. Okay, you figured it out. All right, let's go ahead and read this one. I'm going to have you try to solve this one on your own, and then we'll go through it together. It says, at the end of the school year, there were 2 more students in Trevor's class than there were at the beginning of the year. In each expression below, n represents the number of students in Trevor's class at the end of the year. Circle the letter of the expression that represents the number of students in his class at the beginning of the year. So I'll help you circle and highlight some important information, and then I want you to go ahead and try to solve it. So at the end of the year, okay, we're at the end of the school year, important information. There were 2 more students in Trevor's class than there were at the beginning of the year. In the expression below, n represents, important information again, n represents the number of students in Trevor's class at the end of the school year. Okay. Circle the letter below, the letter of the expression that represents the number of students in his class at the beginning of the school year. Okay, so go ahead and read through that, pause the video, and see if you can figure out which expression you think it would be. All right, let's read it one more time. At the end of the school year, there were 2 more students in Trevor's class than there were at the beginning of the year. In the expression below, n represents the number of students in Trevor's class at the end of the school year. Circle the letter of the expression that represents the number of students in this class at the beginning of the school year. Okay, so we know that, I'm going to write my equation. We know that n represents the number of students in Trevor's class at the end of the school year. Okay, so at the end of the school year, this is what he has, the number of students. And we know that there were 2 less kids, or there were 2 more kids at the end of the school year. There were 2 more kids than there were at the beginning of the year. So I'm going to say that I'm going to do a subtraction. Because if you think about it, this is the end of the year. Let's say there were 27 kids at the end of the year. And at the beginning, if I took 2 away, there'd be 25, right? So basically, I am taking the total at the end of the year and subtracting 2 to represent what there would be at the beginning of the year, which is what the question's asking. So I look at my options. Oh, an A right away is the right one, n minus 2. We're not adding on, because that would mean we added on at the end of the year. And 2 minus n, that won't work because we get a negative number, right? Because we're going to have more than 2 kids in our class. So n minus 2 would be the correct answer. All right, the last 2 problems we're going to look at today are looking at inequalities. It says an inequality is a statement that 2 expressions are not equal. And we've seen these before. We've seen, for example, 5 is greater than 4, or in this case, 4 is less than 5, or 4 does not even equal 5. That's our does not equal sign. So in here, we're going to read the problem, and then we're going to have to choose which one of these inequalities represents what's in the problem. So it says, the cost of one adult admission ticket to the school musical is less than $6. Okay, right away I know that's really important. I'm going to box that. It's less than $6. Okay. Circle the letter of the expression below that represents the cost in dollars, D, of one adult admission ticket. Okay. So I know that I'm looking for the one that's less than. It's going to cost less than that amount, right? And D is the amount of the ticket. So I'm thinking of, I want to find one that shows that the dollars, the cost of my ticket, is going to be less than $6, right? My ticket is going to be less than $6. So that's what I'm looking for. So we'll check. This one says the dollar amount is greater than $6. That doesn't work. The dollar amount is less than $6, or it equals $6. It doesn't say it equals, it says it's less than. So that's not correct. All right, let's try this one. The odometer of a car shows that the car has traveled more than 8,000 miles. All right. Circle the letter of the expression below that represents the distance in miles m the car has traveled. Okay. So in this case, I know that it is greater than or more than 8,000 miles. Okay. So the odometer of the car shows that the car has traveled more than 8,000 miles. So if I write my equation here, I've got my 8,000. And I know that the miles traveled is greater than or more than 8,000. So in this case, the correct answer is A. Great work. So today we talked about expressions and inequalities and talked about how to write expressions out after we read a word problem or how to identify them, and then also how to use our knowledge of inequalities to read a word problem and then recognize an inequality. Great work.